A bus is bigger than a minibus, but they both have similar properties. For example, they are both vehicles, and they are both used to transport people from one place to another. Good day. My name is Kabama. I'm your tutor and the founder of Technology for All Academy, a division of Above Supply and ICT Solutions. Just as a bus and a minibus have similar properties, so does IPV4 and IPV6. For example, they both talk to the same TCP/IP layers, and they are both used to identify a device on a network using the subnet mask. And last but not least, they are both used to route packets from one network to another. Our focus for today will be on IPv6 addresses. What is IPv6? IPv6 is a 128-bit address that is divided into 8 groups of 16 bits hex tags. On our example here, we are having a global IPv6 address, which is similar. I'm not saying that they are all the same, it's just an example. I can compare it to public address in IPv4. In IPv6, every device gets allocated global IPv6 address, meaning there's no need for network address translation as in IPv4, where public addresses you were able to do net on them so that your private addresses on your LAN can use one public IP address to go out of your LAN. On our example here, our subnet mask on IPv6, it's written on side annotation. On our example, our subnet mask is /64, which shows us that the first 64 bits are the network part, the ones that are ruled in brown, and the last 64 bits, the ones which are ruled in green, are the host portion of the address. We have rules when writing the IPv6. Rule number 1, you can drop groups of zeros only once in address and put 2 columns. And rule number 2, we can also drop the leading zeros. For example, in our address here, 2001 remainders 2001, 4AF9 remainders 4AF9, we have our 2 groups of zeros. So we apply the first rule of dropping the group of zeros and then representing them with 2 columns. F equal 3 remain the same, and then as you can see we had 00C. We applied the rule number 2, our leading zeros. We dropped our leading zeros, we have C, and then 00DF, we dropped our leading zeros, we have DF, and lastly we have 49EA/64. You can write or simplify your address in this manner. But not only you can do that. When you configure your router, the router itself also applies the same rules. If I configure that address on the router will also apply the rules and write it the same way that I did. I will show you that in this video today. You'll get to experience it for yourself when I configure the IPv6 address on my router. And also we'll be also covering the types of IPv6 addresses. As I told you, the one that I used here, it's an example of a global IPv6 address. So we'll be covering types of IPv6 addresses. For now, let me show you an example of IPv6 configuration. Okay, as I've promised, let me configure my IPv6 address. Firstly, I open my party and I go to my serial. My console cable is connected on serial COM3. Open. Okay, I press enter to get in the configuration of my router. Then let me type in my password, enable, so that I can get to privilege mode. Type my password. Right now I'm in privilege mode. Okay, to get into a configuration mode, I have to type configure terminal. It will take me into global configuration mode. In this mode, you are able to configure your router. Okay, what I'm gonna do, I want to configure an IPv6 for loopback port 1. Okay, let me type interface loopback 1. Right now I'm in the interface mode, so the commands that I'm gonna be typing, they will apply to the loopback 1. Okay, IPv6 address. Okay, I already wrote my address down. Let me copy my address and then paste it there. Enter. Just want to show you how will it look like. Okay, and okay, let's do show IPv6 interface brief. Enter. As you can see, I entered the address in full. There's our group of zeros. There's my leading zeros. But here, there's my address simplified. As you can see, the group of zeros are being represented by 2 columns, and the leading zeros, we drop them. We only have C here, we only have DF. That's why I wanted to show you that not only can we write it or simplify it like that, even the router itself, it does it for us. It simplifies it for us. And then here, it's a local IPv6 address. as I told you, we will be also discussing the types of addresses. So more on types of addresses later today. Just wanted to show you how to configure the IPv6 for an interface. We have 5 types of IPv6 addresses. Out of those 5 addresses, 2 of them we don't actually see them in our configuration, and the other 3 we do see them in our configuration. I'm gonna start with the first 2 that we don't see. Our first address, we have unspecified address. Unspecified address is when our device doesn't have an IP address or an IPv6 address. Meaning, for example, our device will send a request for IPv6 to a DHCP server using multicast, as we know that IPv6 doesn't have broadcast. So the unspecified address, we represent it by ::/128. :/128 meaning we have 8 groups of zeros. So it will send 8 groups of zeros to a DHCP server requesting an IPv6 address. The DHCP server will get the message and reply with an IP address. So how does the DHCP server know which device is looking for an IP address? So the DHCP server will use the MAC address of the device that sent the message for DHCP IPv6 address request. So to give the device an IPv6 address, it will use the MAC address so that it hands the IP address to the right device. And the second one that we have a loopback address. A loopback address is almost similar to an unspecified address. Loopback address is : :1, meaning : :1 meaning we have 7 groups of zeros, and the last group is 7 zeros, and the last bit is 10 to 1. That's the loopback address. So it's also /128. So to show it, it's : :1/128. And our loopback address is used for testing. For example, we can use it to ping ourselves, meaning to check if our device is still working, our network interface card is still working, and not just for pinging. Also used for other testing stuff, that maybe application testing and all those. It's used for testing. So these 2, we don't really see them in our configuration. So right now we want to talk about the other 3 that we see in our configuration. First being the global IPv6 address. The global IPv6 address is the one that I said it's used to connect us to other networks or to connect us to the internet. As I've said before, I said it's similar to public IP address in IPv4. But the difference being that the global address, every device on IPv6 address gets a global address. There's no need for network address translation as in the case with IPv4. IPv4, we were using NET for us to go to the internet or to other networks, meaning our private IP address would be netted or would be translated to a public IP address in order for us to serve the internet. But in IPv6, there's nothing like that. There's been phased out. Since IPv6, we have a lot of addresses. So every device gets its own global IP address. Similar as I'm saying in IPv4, every device gets its own public address. So to identify it, it's identified by the first 3 bits. The first 3 bits in our global address, they are always 001, with the 4th bit being either 0 or 1. Meaning we have 001, the 4th bit being either 0 or 1. This is binary. Binary. And then in decimal, our first character, it's either 2 or a 3. That is in decimal. In decimal, it's either a 2 or a 3. So in most cases, you will see our global IP address in most cases being represented from 2000 to 3FFF. Meaning, if you see an address that starts with the first octet being at 2000, or the first octet, this is the last address of the first octet, being 3FFF, then you know that is a global address. And even without looking at the last 3 digits, if you see an address starting with a 2 or starting with a 3, then you know that address is a global IPv6 address. The next address that I want to talk about is our multicast address. In our multicast address, let me mark this so that I can have some space. In our multicast address, we have the first 8 bits. We have the first 8 bits being ones. So what does this mean? It means that our first 2 characters in hexadecimals are FF. Our first 2 characters for multicast are FF, and they are represented in hexadecimal. Hexadecimal. So our multicast address, as we know, we don't have broadcast anymore. So when our device gets an IPv6 address, it will join the multicast address that has the parameters that it needs for the communications that is going to take place in. For example, if it is a router, it will join the multicast address that it wants to communicate with. For example, maybe it might be a routing protocol, multicast address. It might be for DHCP. Maybe we have a client or a device that got an IP address, maybe to renew the lease, as we know, DHCP client, it must renew. If it takes some time without not communicating, the IP address will be lost. So it has to renew the address. So for things like that, it will join the multicast address to communicate with the DHCP server, and many more. There are many more instances that we can talk about where a client or a station will join a multicast address. And then, last but not least, we have our link local. We have our link local address, and our link local address, the first 10 bits are always the same. The first 10 bits being the first 7 bits, 2, 4, 6, 7. The first 7 bits in our link local, they are all ones, with the 8th bit being a 0, the 9th a 1, and the 10th a 0. So the first 10 bits in a link local address are like this. In hexadecimal, we have F, E, 8, something. Normally, so it's 0. So this 4, they give us this F. And then we have this 4 group, or this number gives us an E. And then this 2 gives us an 8. Why an 8? Remember, I said the first 10 bits, meaning the coming bit or the following bit is going to be 0, 0. So that's why we get an 8. So the first 12 bits, I can say the first 12 bits are like this. That's why we get FE8. 0 something. Normally FE80. That's our local address. It's normally used by our routers or our routers when they need to form neighbors, meaning like for routing protocol in order to communicate or form neighbors, normally used by them for that instance. So we have that's our 5 types of IP addresses that we have. So I've been talking also about hexadecimal, decimal, binary, but I never dwell on it. I never explained it thoroughly. So what I would like to do, I would like to explain it. The last thing that I want to do is to explain the conversion. We have our binary, our decimal, and our hexadecimal. Binary, decimal, hexadecimal. As we know, in binary, let's say in binary we have 10 numbers, and then we keep on repeating. When we reach the 10th number, we start again, we add a 1. We start again, we add a 2. So on and so forth. Let me show you what I mean. The numbers that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the decimal numbers that we have. We have 0 to 9. Meaning we have 10 decimal numbers. And then when we go, that's why we call decimal. Let me call it myself. Decimal, we call it base 10. Let me write it there. Decimal is a base 10 because there's 0 to 10. Binary is a base 2 because of what? We have 2 digits. We have 0 and 1. It's a base 2. And hexadecimal is a base 16 because we have 16 digits or 16 numbers in hexadecimal. So let me start. Okay, to carry on, as we get to 9, we write 1, and then we start all over from 0 again. 0. That's when we get 11. Let me put dots because I want to go to 15 and I don't have space. I want to go to 15 and I don't have space for 15. So in binary, we're gonna calculate from 0 to 15 in binary. Our 0, we have all zeros. 0, 0, 0, 0. It's 4 zeros. And our 1, 0, 0, 0, 1. That's our 1. Our 2, 0, 0, 1, 0. That's 2. 3, 0, 0, 1, 1. That's 3. 4, 0, 1, 0, 0. That's 4. 5, 0, 1, 0, 1. 5. 6, 0, 1, 1, 0. 7, 0, 1, 1, 1. 8, we have, sorry. 8, we have 1, 0, 0, 0. 9, we have 1, 0, 0, 1. 10, 1, 0, 1, 0. And 11, we have 1, 0, 1, 1. 12, 1, 1, 0, 0. 13, 1, 1, 0, 1. 14, 1, 1, 1, 0. And 15, we have all ones. Hopefully you can see what I did. I tried to put all of them here, that's why I want so small. So 15 is all ones. 4 ones. And then for binary or for decimal to hexadecimal, we have, so let me stand this time. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That's for 0 to 50. So 1, 2, 3, 10, 11, 12, 13, 14, 15, 16. That's why we say it's base 16. It's up until F. So you can use these numbers for your conversion. So this is our conversion chart. I hope this session was informative and you learned a lot from it. Please don't forget to subscribe and to hit the notification bell so that you can be the first to know when we upload our video. And where we did mistakes, or maybe you want to give us some advice, please leave some comment. It will be highly appreciated. Actually, it is highly appreciated, because we learn from our mistakes and we also improve from the, what can I say, from those good critics that we get. We also improve from them. So comments, whether be good or bad, comment is a comment and it's highly appreciated. Hope this was informative, and enjoy your